which slowed down in the landmass crash. I don't remember. But basically, you had one process where more carbon dioxide was being removed and less was coming up. So both of them combined essentially reduce the amount of carbon dioxide in the air over time. So actually, if you look at this interesting, can I use some words? It's actually quite interesting. If you look at just the last, you just look at the last 50 million years, and this is like 50 million years ago, alright, and this is where we are right now, that's the present. Okay? When you look at carbon dioxide over that period, you'll see it's actually going, sort of going like that, and then it's sort of rising. It's not as if it's a linear, smooth line. It's obviously zigzagging. But the point is that the long-term trend is downward. Alright? Both of carbon dioxide and of temperature. Okay? And one guy who studies the carbon cycle said that it's absolutely mind-blowing about the connection between carbon dioxide levels and temperatures in Antarctic operations. Okay? He said that it's a stronger connection between that than the connection between lung cancer and smoke. So what he says is this is like the gold standard in the medical profession. He said, yeah, that there's a connection between lung cancer and which is smoking and lung cancer, and that's like the gold standard in like causation in the medical world. He said the causation of CO2 and Antarctica temperatures is even stronger. It's interesting because here's where we were, the India crashes, and it kind of goes downward. Roughly at about 34 million years ago is when it becomes cool enough for ice to form in Antarctica. And that's the first time in millions of years that you've actually got ice in the poles. Okay? And it happened, I think, for 600 million years. The carbon dioxide has now come down, so people are unclear exactly where CO2 will reach. The most common figure one hears is 750 parts per million. They're now, as you know, roughly 400 parts per million. Yeah? Okay, so that's when Antarctica ice gets formed. Over time, it gets lower and lower and lower. And about 3 million years ago is when it reaches roughly 240 parts per million. Roughly thereabout. And that's actually when ice begins to form in the Arctic. And the reason why Arctic ice is melting first, that's the reason. It was formed at a much lower level of carbon dioxide levels in the atmosphere. Okay? And then of course we reach roughly up until 1750, where it's about 280 parts per million. Yeah? It was again increasing slowly. Okay, just stop me if I'm going on this too long, but it's important to make the connection between carbon dioxide and temperature. Over the last 2.5 million years, we also had ice age, and this is part of your warming question as well. We got in and out of what are called glacial periods and shorter interglacials, between long glacial periods and shorter interglacials. We're currently in interglacial in the last 15,000 years. That's why civilization can develop. Nicer temperature. One of the big factors in the Earth going in and out of the ice ages again is carbon dioxide. Okay. Now this warming question that you're asking about, in a sense the point I'm making, and this is really important, is that it's really crucial to understand the connections between the impact of the Earth's temperature and carbon dioxide levels. Okay. There have been times in the past where the Earth has, all of these are natural processes that happen. In a sense, completely natural. They have nothing to do with human beings. The entire thing. There have been times where there have been spikes in the Earth's temperature, where it's cool, but each time there have been very clear reasons why that has happened. At some time it's been a tilt in the Earth's axis. Okay. And other times it could have been a sudden exposure of methane for some reason. Volcanoes cause the opposite effect, because volcanoes send up a lot of dust and fumes. This happened in 1991 when there was a huge Mount Pinatubo exploded, and then the Earth's atmosphere actually cooled for 30 years. Okay? So, in that sense, people may ask the question that this kind of stuff has happened before. Yeah? The fact is that in each case, there's been specific reasons why that's happened. We need to understand what the reason might be. The fact is now, the point is that carbon dioxide essentially is trapping the Earth's radiation at a particular basically what it's doing is we're trapping radiation at a particular frequency, causing the warming. The second part of this fact about has it happened before or not happened before is one that obviously, like I'm saying, it's not natural, it's really man-made. There are obviously reasons why industrialization, etc. Secondly is the pace at which it's happening. You could say, okay, some warming has happened before, but at what rate has the warming happened? The long-term natural rate at which carbon dioxide goes into the atmosphere and out of the atmosphere is roughly 1 part per million. I'll explain what this ppm is in case you guys don't know care about. Basically 1 part per million every 10,000 years. We are now pushing out carbon dioxide into the atmosphere little over 2 parts per million every year. So that's 20,000 times the pace at which it's happened earlier, broadly speaking. And there have been times when it's gone up obviously faster at certain spikes. The fact is that this current rate is at a pace that is extremely difficult for species and ecosystems and species to adapt. The third part is, look, when that warming or cooling may have happened earlier, there weren't 7 billion people around the planet. You got 7 billion people to be worried about now, which wouldn't have happened 50 million years ago or whatever time ago when the Earth would have warmed. So I think somewhere one needs to make these cultural differences in trying to understand current warming. One, the fact that it's man-made, and the fact that it's established that carbon dioxide and the greenhouse gases is what's trapping the sun's radiation. Yeah. Third part is the fact that it's happening at a staggering pace compared to the Earth's history. The fourth part is that 7 billion people worried about. To say nothing about 1.7 other billion more billion species. We have it talking about. So I hope that is to some degree that particular question. The couple of other things I want to say, which is I'm going to quickly move forward. Yeah, try to do it 20 minutes. Look, the two aspects which get missed out in most discussions of global warming, I think it's important. Which is the way I look at it is that the reason why basically CO2 levels why CO2 levels began to spike up again around year 1750, which is that that's basically the period where industrial capitalism essentially begins and peaks. And look, in my view, you can't complete the picture of understanding global warming unless one somewhere locates it within the functioning of broadly industrial capitalism. Now, it's not easy because you're going to say, what the hell, what else do we have? It's like all those players. But that's not, I think, that doesn't answer the problem, because in some way the roots of global warming lies there. Yeah? I'll have them broadly in 3 reasons why I'm saying that there's the connection. One is the fact that energy sources began to be used on a scale, particularly coal and later oil and gas, on a scale which hadn't happened earlier. Okay? Because these are very dense sources of energy essentially. So that's one thing that happened around the late 18th century. The second part is that the logic of that system is different.